Aloha. Welcome to ThinkTech Hawaii's Education Movers, Shakers, and Reformers, where we look at education from preschool all the way through higher ed, public and private, interviews with people with special insights. I'm Jim Shon, your host, and today we're going to probe the inner workings of the minds of teachers and students from the inner working of the minds of those who develop curriculum. My special guest is Dr. Frank Pottenger of the Curriculum Research and Development Group at the UH. He has been in curriculum development for eons. Welcome, Frank.
Thanks, Jim.
And tell us a little bit about how you got drawn into this curriculum development and what the heck is it?
Well, my history goes way back.
Not that far, no.
Well, actually, it really goes way back. I'm a dyslexic, and I have suffered from that all these years, and it took me a long while to get to the point where I could read. But once I learned to read, the world just suddenly opened to me, and I was able to get a good degree in science, and found myself in the military. And like everybody who's in the military, when you come out, you wonder what you're going to do. And my mother-in-law found a job for me in a small rural school in Ohio, and I became the science teacher while waiting to go back to law school, which I had hoped to do, and fell in love with it. And the incredible thing to me was the way kids actually do learn. The difference between a good teacher and a bad teacher makes all the difference in what happens to kids, because the good teacher is able to look at content and able to manipulate it and get it so that it is functional within the head of the kid. My dyslexia gave me the insight of what so many of these struggling kids were actually going through. And this, I thought, was probably the best way to coming into the field of education, was to have a problem yourself so that you could learn from the kids how almost to solve your own problems in process.
I see. So you first got involved teaching science.
Science.
Your own disability really gave you insights. But then you drifted towards this arcane, interesting world of curriculum development. How did that happen?
Okay, let me tell you how that happened. There was a marvelous person by the name of momentarily Jim Shon, who I worked with on the chem study program. I was teaching in Whittier at the time, and Jim took me to a meeting that had all the greats who were working on the chem study program. Remember, we had two programs that came out in the physical science. We had the BSCS in the biology, and we had the PSSC, and we had the chem study. I was part of that chem study group, and I suddenly found that they could use my writing. So I became a writer of test questions, and that was my entry into it. I had no idea that I could do it, but due to the fact that I had a wife who was an English major and could correct all my dyslexias, it made it possible for me to get into the field. And it was remarkable to be part of that particular group, because it was making such a huge change in American education at that point. And you could just feel it in your marrow when you were meeting with these people who were pulling together a brand new idea and a brand new approach to materials to give to kids in high school.
So you're a teacher, but also you become a writer.
Yeah.
So curriculum development, at least in those days, was a lot about being a good writer.
Right.
With clarity. And you want to talk a little bit about that importance of...
Well, the big problem was that the chemistry that had been done prior to that time was a chemistry that built mostly around the technologies. You could learn how to distill water, you could learn how to make a good salt solution, and if you wanted to make gunpowder, you could find out how to make gunpowder. But what had been missing was the theoretic base. And this was considered to be sort of the plot that the universities put onto the kids once they got into the university. But the NSF had the wisdom to say, look,
NSF is the National
Science Foundation had the wisdom to say, we have got to get these kids engaged in looking at the theory and understanding the theory, because if we can get them into the theory, then the understanding of the technology will come afterwards. And it was a brilliant solution to the work. So I brought my collegiate work through this. I spoke well, so therefore I learned how to write well. But as I say, I had to have assistance in the writing, and it was a true adventure to get started in this and to have people who were so knowledgeable in what was actually happening in the academic world of this.
So you're on the mainland,
On the mainland,
doing chemistry development or curriculum development and theory at the college level, I guess,
this was
right?
at Harvey Mudd.
Yeah, and which is one of the most prestigious institutions we have. And so then you arrive in Hawaii. How did that happen?
Well, that was a sheer accident. You know Art King. He was a member, of course, of the College of Education. He was in charge of CRDG.
Curriculum Research Development Group.
Wonderful name.
Yeah.
And Art was given the charge to change completely the way that the lab school was used. And what he did, he transformed the lab school into a curriculum design center. And his basic theory was completely compatible with the chem study philosophy, which was that the focus should be on the content that you would find in a university course. And he was committed to that to his last day, and it has driven everything that we've had at the lab school and at the College of Education, CRDG.
So in his theory and his approach, the disciplines of science and I guess history or whatever, these form the framework, the questions you ask, the knowledge you cull from it.
Yeah, well, you've been around this long enough. We have two basic tenets. Tenet number one is that the background in the history and the fundamentals have been developed, but they were done sequentially, and there was a storyline that was behind every one of these ideas, and they built one upon the other, and they created the materials that we now consider to be the basic biological, chemistry, and physics background behind what we teach in schools. So the beauty of Art's approach was, he said, go back and look at history. Try a recapitulation of the historical so that you have all of the necessary pieces in sequence, and you are therefore able to bring the kids in so that they're having a experience very similar to the original designers. This is of course the beauty of working in curriculum, because you can take the historical, you know what the historical is, and you can pull out of it the seminal pieces of work, and you can get the kids to rediscover, literally, the science that is behind that set and sequence of information.
So the journey that society, science has traveled in any particular area, where they first discover one thing and then the other, that discovery journey you're trying to recreate for students in their classrooms and from semester to semester and whatnot.
This is basically what it is, and it you can mix, and this is one of the things that comes from the STEM notion. When you're looking at science, technology, and you're looking at the mathematics that go with it and the engineering, you can mix the engineering and the theory, because the engineering and the technology pull their basic information out of the theoretic base. However, we have to recall that the whole range of things that we now have in the sciences came initially out of technology and engineering. Human beings were technologists and engineers.
Problem solvers.
Problem solvers,
yes.
long before they were actually theoreticians. So this was, well, all you have to do is go back and look at Rome. And just think, how were they able to raise those columns, those huge granite pieces, and get them so that they were set in such a way that they're not going to fall over with a slight earthquake. You know, all of this was worked out before Christ in terms of its work, and it was the grounding point for the Grecian attempts to understand the world of astronomy and the rest of it. But it was because of the fact that people were building on each other's basic background that they were able to accumulate all of this richness that is now part of our theoretic structure.
I think it's fascinating that you're a scientist, and yet you're talking about history
Yep.
and civilization.
Yep.
And you've also talked about how the lab school, which I guess originally was kind of a teacher training school, is morphed, transformed into a laboratory, literally, for testing out, developing curriculum
Right.
that's problem solving, inquiry based, that whole approach.
Completely. And it means that when you get into an environment like that, and when I first came to Hawaii, I taught in the middle school because the middle school was our target of what we were going to be looking at. And I taught 3 grades of middle school. And I had 9 kids that I was able to work with. So every night I would go home and come up with a new experiment. And we were able to, I went back and I looked at the old physics books. I looked at the old chemistry books to see what had been done in the last century and how it worked its way to the present, and was able to draw from that the kind of experiments that really excite. You take a child with a bottle that is filled with water, and you have holes in the top of the lid, and they squeeze that, and they suddenly find that there is an ejection of water. You squeeze it a little harder, and the ejection is higher. You squeeze it a little higher yet, and the ejection is even higher. Now you turn it upside down, and it works the same way. You put it sideways, and it works the same way. And it doesn't make any difference what direction you put it in. It works the same way. And this finding of this universality of pressure in the reaction to fluids is, it sounds simple, but there are so many different kinds of technologies that are based upon that. Fire hoses, all of these things are based upon exactly that same basic principle. And it's when you can go down to the simplicity of that sort of thing, get kids to see it, then you're ahead of the game.
Fantastic. We're talking with Dr. Frank Pottenger about how you approach leading children into, and students into discovering their own knowledge. This is ThinkTech Hawaii, Education Movers, Shakers, and Reformers. I'm Jim Shon. We'll be back in 1 minute.
This is Alice Lee Hagan, host of ThinkTech Hawaii Business Education Spotlight. My show here at ThinkTech Hawaii is every Thursday from 3 to 4 in the afternoon. I bring in interesting guests from Hawaii, the mainland, and hopefully international guests in the future. Do join us on Thursday from 3 to 4 p.m. ThinkTech Hawaii Business Education Spotlight. Aloha.
Aloha, my name is Josh Green. I'm a senator from the Big Island. I work in the ER there. But on Tuesday afternoons, I get to come and spend 45 minutes to an hour with Jay Fidel and the ThinkTech staff. They're terrific professionals. They help us to bring some of the leading cutting-edge topics here across our state to you. So you can join us at our show on healthcare in Hawaii to talk with leaders from across all the spectrum of health in our state, or you can join us for any other show where we talk about economic development or tourism or some really eclectic programs too. So really, we'd love to see you here on our show. Thanks for joining us and thanks for supporting us.
Welcome back to ThinkTech Hawaii's Education Movers, Shakers, and Reformers. We're talking with Dr. Frank Pottenger, spent a lifetime and getting inside the minds of students and helping them discover their own knowledge. Frank, you mentioned earlier that the laboratory school, the University of Hawaii Laboratory School, has been a place to develop curriculum. And I know there's a couple of fantastic science programs that you've developed over the years that you've taken nationally, even internationally. Tell us a little bit about that.
Well, we first started at the middle school, as I indicated previously. And that was because when we came to Hawaii, we had Sister Edna DeMontier in the Catholic school system who had developed a wonderful program in the local ecology. It had no physical science component, which was a parallel to it. And it needed, in order to completely flesh it out and to satisfy the needs of kids, it needed to have the physical science as well as the biological science. Sister Edna came to the lab school, joined forces, and she opened up the world of the science side of her technological approach that she had used originally in her biology. She was interested in agriculture originally. She was interested in what happens to pineapples and how they're grown and all the rest of it, which is absolutely fascinating. But what she wanted to do was to look at the biological history and to see biology as a way of getting the kids to understand more completely what the natural ecology is. So I was given the task of creating the physical science. And again, the easiest thing to do is to go back and look historically. And the place that the history really comes together is in the water. I gave the illustration previously of a squeeze bottle. There are so many things that came out of the pneumatics that the ancient Greeks, Middle Eastern scientists used that were truly amazing. So what we did, we started out, we got the kids so that they were able to understand the ideas of pressure, were able to understand the ideas of buoyancy, were able to understand why it is that ships can have ballasts that are going to be of iron and have to have ballasts of iron in order to actually be stable. All of these things came out of it. The fun part was when we finished with the intellectual side of looking at the mathematics and the other aspects of the science, that we would always come to a practical demonstration to show how this really was brought about. The submarine is the first project that the kids engage in. And they are told that they have to have a submarine that they can sink, that they can bring it to the surface, and it will float, and it will move. And it has to move horizontally. And it's just incredible what will come out once the kids understand what the nature of buoyancy is, what the nature of forces in fluids are. Then you can move to wonderful things like the atmosphere. And you can start talking about how the atmosphere is here reliant upon changes in temperature, and how you can get evaporation, and these will give you clouds. The whole rest of this type of modern infusion of understanding of atmospherics we get into. After we developed 3 years of program and got extensive National Science Foundation funding for this, disseminated nationally, probably 2 million kids have been through the program.
2 million?
Something of this order.
Wow.
It's fairly extensive in terms of its distribution. We were tantalized with a request from our colleagues in National Science Teachers Association to try the elementary, because this had not been, it had been done, but it didn't have a storyline. The works that came out were bits and pieces of really exciting things that kids could do, but it wasn't tied together. And our story, our approach has always been storyline. So we began with the setting up a completely new program. But again, remember I said originally we were technologists before we were scientists. So when we attacked the elementary school, we began immediately with the technology as the point of focus. So the children from the very beginning were dealing with the full range of technologies that are the practical technologies that exist in. One, how you actually can plant a garden and you can get that garden to grow, and what it means for the animal world and how the interaction between plants and animals. So you have this wonderful kinds of operation. So we got the biology. We looked at astronomy, and the astronomy was also part of the seafaring experience of here in Hawaii, and there was a natural interplay. You may remember Will Kasoka.
Yes.
Will gave us the direction, and we worked at that to be sure that we were able to get the kids to understand that there's a thing called summer and winter, and this has a consequence that comes directly out of the movement of the earth around the sun, and that there are seasons, and these seasons affect the gardens that they were growing, and they affect the animals that are part of it. So they suddenly got the idea of natural history, which was very, very important up until the time of modern biology, which now includes so much chemistry and the physical science. So what we did, we went further back, and we got the kids so that they were interested in such things as how foods get into the supermarket, how the foods that are in the supermarket are then transformed into edibles. So they grew their foods, they ate their foods, they made surveys to find out where all the food came from, how it got to Hawaii and how it was transported here, and what it meant economically. Because when you're dealing with technology, you cannot leave out the economics. This is so critical to the actual delivery. And the economics became very, very important. Then the nutrition also became part of that elementary program. So we came into a world which was one of true practicality. We wanted them to understand that you have to do many things in order to make the world work for you. And this is what we wanted to get these kids to realize, that they were learning how to transform the simplicities of natural history into the complexities of the world of agriculture and others, and how this was working for them in process.
So you were STEM before there was STEM?
Yeah, we were. We worked at the whole range of things in the STEM area. Also the mathematics, of course, became automatic. And the fascinating thing is, of all the mathematics, geometry is my favorite. When you take a look at the world of astronomy and what you have to do in order to locate planets and others, and the use of the telescope, and how you can then actually come up with a very beautiful mapping of the Earth in terms of its astronomical pieces. We got into all of that, and interestingly enough, it has been demonstrated that at grade 4, kids are quite able to handle a tremendous amount of basic geometry.
Grade 4?
Grade 4.
Usually grade 10 or something, right?
It's a very late program, but it's so conceptual. You can see it. You can make things out of it. You can get the kids to make their own telescope, which we do, and they're able to actually determine what the bearings of the North Star are and others, and why it is that there's a constancy of the North Star. All of these things come together in terms of the math as well as the basic science.
Well, and it sounds like, in a traditional school, if I can use that term, we marched them through a series of kind of compartmentalized subjects, and it's not holistic, it's not STEM. And we say, you'll learn algebra here and geometry there. but you've taken the problem-solving curiosity of mankind, if you want, and jumbled that all up. So it sounds like that program, which I think you're talking about, DASH, the Developmental Approaches to Science and Health, that DASH approach seems to me is going to have to struggle against our traditional school system curriculum sequence.
Where it has been used successfully has been used incredibly successfully. Very high test scores and others. But as I've told you many times, the program for a period of time was completely out of sync with what was being required for the No Child Left Behind.
No Child Left Behind
Right.
was march it through in a traditional way.
In a very traditional way, and it set up a curriculum which did not have any storyline to it. It didn't have any way of connecting. It didn't have any way of getting the children to see that this is a life that they're living, which is a holistic life. Right. And instead, it was a series of very interesting little experiments. We're going to make this clown balance upon a point. Okay, if you don't do anything with that balance point, what is the reason for it? And what we've done, we've always gone to what is it is basically used for. And that has been very important to us.
That's fascinating because the critiques of No Child Left Behind tend to be teaching to the test, overemphasis on just 2 subjects, and recently trying to tie high-stake test scores to teacher evaluation. Yeah. But you're raising another, maybe more important issue, that whole movement of testing and sequence has worked against students' holistic understanding of the world.
Right, it has. And, well, we also have a marine science program, as you know. And due to the fact we live here in Hawaii, it was incumbent upon us very early in the game to start the study of marine subjects in the curriculum. So what we did, we took the 8th grade portion of the FAST and inserted our program, which has 2 components, the fluid earth and the living ocean. So it deals literally with the liquid body out there and the organisms that live within it. And what we were able to do was really bring it together at this particular point in time, because the interface between the water and the land and the atmosphere and the technologies that human beings are using in order to actually take advantage of these the tremendous resources and wealth in the ocean. It was a study of itself, and it is ideal. Kanisa Seraphin is now continuing this, and she's got an extensive program in the study of the ocean.
It sounds like, though, that this shift is going to require, or does require, a fair amount of professional development for teachers.
Yes, and that is part of it. One of the things that is so interesting is to watch kids who come into the program and are first timers, and the transformation that occurs is just amazing.
Well, we're talking with Dr. Frank Pottenger about how to bring children and students and even teachers into a more holistic understanding of the world, science, STEM, whatever. We'll be back in 1 minute.
Okay, this is ThinkTech Hawaii, and it's Wednesday. Every Wednesday is Energy Wednesday here in Hawaii, the state of clean energy. 4 to 5 p.m. every Wednesday. Come and listen to us. And just to show you what I mean, I'm going to ask Sharon to tell us more.
Come and see us every Wednesday, as Jay said. And we have people like Jim Albers from HECO here, and co-host Ray Starling here every Wednesday. We not only go on Olelo and OC16, but also stream live. So please come visit us, hear about the latest in clean energy.
Okay, Jim, you've been here. You got any comment on all this?
As important as energy is in all of our lives today, this is a great forum and a great format to vet those issues. So I encourage everybody to listen in and participate.
Okay, Ray, what do you think for a close?
Well, I think this is the greatest show in the energy world here in Hawaii. You can come here every week, 1 hour, and catch the latest on what's happening and hear from the people who really know what's going on, like Jim Alberts. We appreciate your coming today.
Thank you.
Ray Starling, Sharon Moriwaki, Jim Alberts, and Jay Fidel here in Hawaii, the state of clean energy, 4 to 5
Aloha.
p.m. Wednesday. Aloha.
Aloha.
Welcome back to ThinkTech Hawaii's Education Movers, Shakers, Reformers. We're talking with Dr. Frank Pottenger about all the aspects of leading children into discovery of a holistic world. And we were just starting to talk about teachers and how teachers can make that shift from a kind of plodding curriculum to one that it really excites students. Talk about your professional development that is needed.
Well, let's take a look at what teachers need and what they feel that they need and what is necessary in order to bring about a program like this. First of all, this is not the way they were taught in school. Even if they were disciplinarians, they were usually not. History book or chemistry books are actually fairly recapitulations because you have to have the logic of the development of the basic equations, and they develop out in an incremental way. But the idea of bringing this together and showing how it's not just the science that is involved, but it's also this technology. Most teachers have never looked at the world technologically. They have not really thought about how it is that this technology around them is what allows them to survive. And they don't see that when they cross the street and those lights flash, that they are synchronized, and that synchronization is part of a vast network of synchronized lights so that the traffic will move. They don't think in terms of this. They instead, it's part of the world as the child would see the world. So what we found very early in the game is that the teachers have about the same actual understanding as children when it comes to the technologies, the basic technologies.
The engineering.
The engineering and the rest of it. So we were able to use the materials that we were using with children and to use this as a way of informing teachers so that they became capable of actually transmitting the ideas.
So you're not lecturing the teachers in PowerPoint,
No.
death by PowerPoint. You're taking them through the same process.
Same process. And taking it through the process, we add a little bit of extra so that they have that sense of superiority that teachers have got to have in order to survive in a classroom. It's an essential. But what we have, we've created a classroom where the child is a researcher and the teacher is the research director. Now, we actually have it role-playing, and all of the behavior that you have in that classroom is here very similar to that you would have within a university setting. There are stipulations. You have to be honest. You do not fabricate information. You will be working in small groups, usually groups of about 4 or 5 as far as the students are concerned. So they're controllable. And what you have then is the teacher, rather than dealing with the whole classroom, they have a group of cellular learners that are able to, in effect, teach themselves many times things that would have taken the teacher's time to explain, but somebody within a small group will usually have insights that will possible to drive the inquiry that is occurring within that group and give it some sort of a focus and completion. In this program, we have the greatest endpoint that we want for kids is to be able to teach. They should be able to take the role of by the time they're finished with this program, of the teacher director, and they should be able to teach their peers. So when we evaluate the kids, we put them on a scale, and they are approaching the capacity to actually teach their peers what they are learning. And this changes completely the nature of the classroom, because the teacher now has 28 helpers, 28 people who are out there who have the same responsibility that the teacher has in order to get information across to peers and to operate. So what we've done, we've greatly reduced the pressures on teachers by this technique of making the child who they are teaching aspiring to be able to do this, so therefore the child sees this as a responsibility and will operate. Now, as you know, every child is not going to follow this, and you will have all sorts of behavioral problems within classrooms that require special attention, and when you don't cease to be a teacher in this, but you do have the structure which is there that can be looked at, and you can give the kids the insights as to the way that they should actually behave.
So you're bundling a more holistic, multidisciplinary approach with a completely different, really, teacher engagement
Right.
Approach. And now we're looking now, let's go look into the future. It seems to me that curriculum development has been just a tremendous possibility in Hawaii, but not really seen as an industry that it could be. We have
Yeah.
so many insights,
Yeah.
so many resources.
Well, to give you some idea, we have made several millions of dollars in disseminating the materials that we've produced at CRDG. And the beauty about Hawaii is that there's a single school system. And it is possible, therefore, to replicate an experience in many sites. And as a result, you can get incredible evaluational information. We probably have some of the best evaluation information around, simply because of the mechanisms that are set up here in Hawaii for the teaching of kids. We also have not only the public schools, but we have a very large private school segment that is out there. And that private school group, our reputation is such that we've been very successful in getting private school buy-in to the utilization of the materials. And then there's a third component, which is the charter school system, which has it's supposed to be different from the Department of Education. It's supposed to lead the way. Well, they've oftentimes picked up our materials and use that to lead the way. So what we have is absolutely invaluable opportunity to test out materials, to demonstrate the ones that are truly effective, and to actually then go out and disseminate them. As I said, we have disseminated our marine science program alone has brought in several millions of dollars through the university, which have been putting back into the research. But that one program in that dissemination has been extremely effective.
It does seem like when decision makers talk about K-12 education, they're thinking what you might say retail.
Yeah.
We have a system and we're
Good.
going to teach kids. They're not thinking of an industry,
That's right.
an entire sector where Hawaii can create a very valuable economic niche. And I'm wondering if you have any thoughts on where that could go for us and how we could do that. We now have the internet. Does that help us or hurt us in this?
Well, the internet is probably the greatest thing that has come along because it is it's an auxiliary memory, that's what it amounts to. And the amount of stuff that is now on the internet that is of true quality, and not just in science, but in social science and economics, you name it, there are wonderful resources that are out there. However, we forget that you cannot use the internet and the development of the computer delivered system alone. You have got to have that interaction, that human interaction. And I was talking about becoming a teacher. You don't become a teacher by interacting with a TV. You become a teacher by interacting with people. And I've said this flippantly with my colleagues. It could well be that the school is going to be the only place left for people to actually become humanized because of the, well, you know what's happening with the games playing where kids get so enraptured with this that they lose all bearing. And the beauty about the approach that Art took with the disciplines is
Art King, yes,
is that there is a set of demeanors and ways people treat each other when they are actually designing programs. This is the way the program that you and I worked on in Russia. You remember what we did? We told the Russians, look, you don't need to have a new civics program. You've been actually dealing with civics for years because you have been disciplinarians. You have had the basic structures of an inquiry system already, which is one of sharing, one of working together, operating in an honest environment, all of these things which are the same elements that you have in civics. And this is why the program was so extremely successful in Russia.
Yeah, so we have been successful internationally.
Yes.
We've been successful with many jurisdictions picking up the good work you've done on the mainland, and in Hawaii to some extent, but you know, you're often an orphan in your own hometown here. And it does seem to me that we, as you pointed out, we have the perfect components here to really create an industry that education will respect and borrow from, yeah?
Absolutely, and it's something the lab school still is in operation. We're still using this at CRDG. We're still developing curriculum at CRDG. And the only thing of it is we have not been able to use it as effectively because of funding issues that are now the bane of every institution across the mainland which is attempting to do curriculum. The monies are just not there. But there is a strong possibility that things will change.
Well, we can always hope. You know, quality curriculum, quality teaching, it seems to me might have been devalued in the last few years of unappreciating what it takes to do it well, what it takes to do it right. And Curriculum Research and Development Group at the UH has learned how to do it right, has done it right, and has really built a fantastic reputation. This is ThinkTech Hawaii, education reformers, movers, and shakers. We've been talking with Frank Pottenger about the interesting world of curriculum development by being inside the mind of a student and inside the real professionalism of a teacher. Thank you very much, Frank, for a lifetime of building this industry and continuing it. I'm Jim Shon. We'll be back next week with our education show. Mahalo.